Okay, calculus, we're on day 6 and we get to look at the quotient rule today. But I thought I'd just show you something on the graphing calculator. I know some of you aren't as happy with the graphing calculators as you might be with Desmos. But I haven't found this same application on Desmos. That doesn't mean that you won't, because you're smart and go to it. But I'm going to just show you something here that can be very helpful for checking your answers. So if we have this rational expression, 3x minus 4 over x squared plus 5. I've zoomed in on the graph of that thing, and we want to find the slope of the tangent at x equals 1. I can get the graphing calculator to do that for me. If you look for the button Draw, so it is up above Program. If I do Second Function Program, and I ask it to draw something, it will draw, number 5, the tangent. So at the bottom, it's already decided you want the tangent at x equals 0. We're going to override that and just hit the number 1. So it now says x equals 1. If you hit enter, it will draw you the tangent line at that place and also give you its equation. So as you can see, y equals decimal 5 repeating is the slope of the tangent, and that's what we're trying to find in this exercise. So we are hoping to find a slope of decimal 5 repeating, because that's what I found on the graphing calculator. So that can be a helpful tool. Let's write that down so you've got it on record. So for the calculator, it would really help if I could spell. You would type your equation in under y equals, and then second program, which is the draw function. You would choose tangent, and then just hit 1 for x equals 1, and it will give you the equation of the tangent line at that place. All right, let's do it algebraically. We can always use the product rule to solve this thing. So let's just look and use what we're already familiar with to find this derivative. So if I were to write the function looking like a product, I would have 3x minus 4 times x squared plus 5 to the negative 1. And I know from yesterday how to find the derivative of that. My derivative would be the derivative of the first, which is just 3, times the second, exactly the way it is, plus the first, times the derivative of the second, where I bring down a 1, negative 1, I'm sorry, reduce the exponent by 1, don't forget the guts, done. I could certainly tidy that up because it is pretty ugly. It would be 3 over x squared plus 5. That's better. For the second piece, I have a negative, a 2x and a 3x minus 4 all over x squared plus 5 squared. We just really don't like negative exponents, so that would be a better answer. We could continue with a common denominator, but since I know I want the derivative at the value 1, I can figure that out numerically. I would have 3 over 1 squared plus 5 is 6, plus negative 2 times, put a 1 in there, I have negative 1 all over 6 squared. I have, if I had 36, I would have 18 plus 2. I'd have 20, 36. You're trusting me, are you, with a common denominator in my head? If you did 20, 36, and you were to reduce it by a factor of 4, you would have 5/9. And guess what? 5/9 is decimal 5 repeating. So we found it by using the product rule. I'm going to give you the quotient rule. If you have a function that looks like a quotient, g of x over h of x, then our derivative is the derivative of the first times the second. Looks familiar. Subtract the first derivative of the second divided by the second squared. So the subtraction is different and the denominator is different. Let's do it. The derivative is, using the quotient rule, the derivative of the top, which is 3, times the bottom exactly the way it is, x squared plus 5. Pause. Subtract the top, don't know why I said that so strangely, the derivative of the bottom, and the derivative of the bottom is 2x, all over the bottom squared, x squared plus 5 squared. That is our derivative. We can tidy that up and it would look a lot like the tidy up we did before with a common denominator already implied. Let's do one more line. I would have 3x squared plus 15, subtract, I'm doing distributive law and subtract at the same time, so bear with me, 6x squared plus 8x over x squared plus 5 squared. I end up with negative 3x squared plus 8x plus 15 over x squared plus 5 squared. The derivative at 1 would be negative 3 plus 8 plus 15 is 20 over 1 plus 5, which is 6. 6 squared is 36. What do you know? That's about decimal 5 repeating. I'm going to do the first one of these three and ask you to do the other two at your tables. But let's do the derivative of x over x plus 1. My derivative is the derivative of the first times the second. Subtract the first derivative of the second, which is the derivative of the bottom, x plus 1, which is a 1. I tend to write those even if they're redundant, so it shows that I thought about it. All over the bottom squared. A tidy up would be great. I would have x plus 1 subtract x over x plus 1 squared. 1 over x plus 1 squared. Try the other two at your tables tomorrow.